right, good people, this is part 2 of the section 1.3 video. We're going to pick up with the slope of the line. So the slope is defined as the vertical change divided by the horizontal change, or we also commonly see it or we hear it as the rise over the run. Let's say we have two given points and they pass through these points. Well, if we wanted to find the slope denoted by m, we would say that y2 minus y1 divided by x of 2 minus x of 1 equals to the slope, okay? Which is still the same thing as finding the vertical change divided by the horizontal change. If we look in the graph, you see the rise and the run, or the run over the rise. Okay, so a key thing I also want to point out really quickly is the slope of a vertical line is the undefined because 0, right? If we have 0 in our denominator or is in division, then it should be undefined. If the slope of a horizontal line is 0, well, that means if my slope equals to 0, then it's going to be a horizontal line. If my slope equals to an undefined number, then that means it is going to be a vertical line. But before we get into the nitty-gritty of that, let's find some things algebraically. First example says, find the slope of a line passing through the points -7, 3, and 5, -1. So the first thing that we need to do is we need to label our points. This will be your x of 1, this will be your y of 1, this will be your x of 2, this will be your y of 2. So now I plug it into the formula. y2 minus y1 over x of 2 minus x of 1. So this should now give me -1 minus 3 divided by 5 minus -7. So -1 minus 3 is going to give me a -4. -5 minus a negative, 5 minus a -7, two negatives make a positive, and that should give me a +12. So now we have -4 over 12. Well, we can simply reduce that at least by 4. 4 goes into 12 a -1 time, and 4 goes into 12 a -1. 4 goes into 12 3 times. Okay, and so my slope will be a -1/3. If we try it one more time, just for clarification for you, if I wanted to find this slope, again, I label my points: x of 1, y of 1, x of 2, y of 2. So we plug it into our formula, y2 minus y1 over x2 minus x1. This should be a -1 minus 3 again. I guess I've selected the same numbers. And then this should be 5 minus 5. Well, in this case, I end up with a -4 over 0. And since I have 0 in the denominator, this means it is going to be our slope, let me say that, our slope is going to be undefined. Okay? And we just talked about it a minute ago that if we have an undefined slope, if we were really looking for an equation of that, then it would be a vertical line. So let's talk about the relationships really quickly. If you look at this graph right here, the slope is going to be positive. Okay? Anytime that the graph, right, rises up from left to right, that means it's going to be a positive slope, meaning the slope is greater than 0. Anytime we see the graph falling or decreasing from left to right, that means the slope is negative, and that means it is less than 0. So meaning if my slope is m equals to -4, that means it is obviously a negative slope. So it's going to fall, right? If I have m equals to +5, that means it's a positive slope. So that means it's rising, right? This means increasing, and this means decreasing. I'm sorry for the horrible handwriting. Okay? Now, I just talked about the same thing a minute ago as well. If you look at our slopes, right, I say that a slope of a horizontal line is 0 because a horizontal line has no vertical change. It has no rise. So between the 2 points, right? So this is what it looks like when your slope is 0. It is a horizontal line. It goes straight across whatever value of y is given. All right. So meaning if it says y equals to 4, that means 1, 2, 3, 4. That would be our horizontal line. Oh, that's a horrible color too. Okay. My next thing is the vertical line. So if I look at this vertical line, that means that my slope is, again, undefined. All right. So, and it does not exist, meaning there is no rise. Okay. So, again, if I give you a quick example, if I said x equals to 4, if this is 0, 1, 2, 3, 4, that means it's a straight line up and down at 4. And again, that means my slope is, again, undefined, or AKA does not exist. All right, so slope and y-intercept of the line. For the slope of a graph of the equation y equals mx plus b, the y-intercept is considered to be the b, right? Or 0b if we actually want the exact number. So if we are given equations, we should be able to determine not only a few things, but the slope and the y-intercept. Okay? Clearly remember that m means the slope, okay? And the b means the y-intercept. So for example, A here, if I look at it, I have y equals to 7x minus 12. Well, this is easy. If I write y equals mx plus b right above it, the m is indicated by the 7 and the b is indicated by the negative 12. So my slope, right, m would equal to 7, and my y-intercept would be 0, negative 12. Okay? Now, sometimes things are not as easy as they seem when they're not in slope-intercept form. We can change it into slope-intercept form. And again, the way we change a slope-intercept form is it has to be written in y equals mx plus b. That's the slope-intercept form. So in this case, we would need to solve for y. So I need to subtract the 2x from both sides. And then I have negative 3y equals to negative 2x plus 12. Still solving for y, I'm going to rewrite it here. I would need to divide by negative 3. And y would equal to positive 2/3 x minus 4. So from this information, I can gather that the slope is 2/3 and the y-intercept is 0, negative 4. Okay? So, of course, in anything in mathematical modeling that we are doing, we always want to have some type of word problem, right? So, example 5. The amount of money Y remaining to be paid on a loan is $60,000 with $16,500 of interest. Is Y equals to the 76,500 minus the 1275x, where x is the number of monthly payments that have been made. Oh, this has come back to haunt us again, right? So the question is asking us, what is the slope and what is the y-intercept of the graph of this function? So what is the slope? Is this written in slope-intercept form? It actually is not. Notice the x is here. So if I write it in slope-intercept form, it should be y equals to negative 1275x plus 76,500. All I did was rearrange. So now looking at this, my slope would be a negative 1275, right? And then my y-intercept of this would be 0 and 76,500. Okay? Constant rate of change. So a rate of change of the linear function y equals mx plus b, and m is the constant, the slope of the graph, right? So what I mean by that is a rate of change is always or can be denoted by the slope. It is the same exact thing. We're just trying to say it in a slightly different way. So in this example, right, it says using the data and projections from 1990 to 2050, the percent of Hispanics in the U.S. population can be modeled by h of x equals to 0.224x plus 9.01, with equal to the number of years after 1990. What is the slope of the graph of this function? What does the slope tell us about the annual rate of change in the percent of Hispanics in the United States? So if I'm looking at this, this is in slope-intercept form, right? This is technically, remember we talked about it, anything of x, h of x, y, f of x is y. So we're saying this is y equals to 0.224x plus 9.01. So if I'm looking at my question, it's just only asking me what is the slope of the function. So the slope is 0.224 because it's right here indicated right in front of this x. Now, what does the slope tell us about the annual rate of change of the percent of Hispanics in the United States? So the slope tells us that if we pay attention, the slope tells us that it is increasing by 0.224 each year since 1990. The percent has increased by that percentage point. Okay? And that is what the information is telling us. Now, we have one last example. More applications. A company produces and sells a smartphone with a revenue of R of X equals to 89.50 X dollars and cost given by C of X equals to 54.36 X plus $67.90. Where, I'm reading it horribly, huh? Where X is the number of smartphones produced and sold. So, what is the marginal revenue for the smartphone? What does it mean? That's our first question. Then our second question asks us, find the profit of the function. Then our third question asks us, what is the marginal profit for the smartphone and what does that mean? Okay, so the marginal revenue, right, is 89.5, because R means revenue, right? Is 89.5 units, right? So that is what our marginal revenue is 800, not 800, $89.50, right? Is our marginal revenue per unit sold. So this means that the sale of each additional smartphone will result in a revenue of $89.50. That's number one. Number two, it says find the profit function. So the profit function is, I gave you a little bit of a hint, but the profit function tells us you do the revenue minus the cost. So what is my revenue function again? 89.5. So 89.50 minus the cost function, right? Which would be 54.36x plus 67.90. Okay? So if I do that, let me get my calculator. 89.50 minus 54.36 is 35.14, right? 35.14, right? X minus 67.90, right? So that would be our profit function. This is our profit function. Okay? Again, that's the revenue minus the cost. Now, I guess you're asking me, why is this a minus? If you distribute that minus sign, it should become a negative 67.90. So it says, what is the marginal profit for this smartphone and what does it mean? So if we have a rate of change for the profit, which is the slope of the graph, therefore the marginal profit would be $35.14, right? Per smartphone that's sold. All right. And the production and the sale of each additional smartphone will result in an additional profit of $35.14. Okay. So it's just more or less kind of reading into the information that you have. All right. Well, that's the end of section 1.3. I shall gather you another video on section 1.4 very shortly. Thank y'all. Ooh, that was a long video.